everybody. Today I'm going to talk about refrigerant gauges, how we use them. I'm going to start doing more videos and live instruction in front of an actual refrigerator to show you guys, instead of show you guys pictures or just videos, so you can ask questions. But I don't go back to work till next Friday, and then we got the Thanksgiving holiday coming up. But the next sealed system class, I hope to have a product that I can use for demonstration, and you guys can see this is how we connect this is where it goes and everything else. I'm going to be more into the actual usage of the gauges, how to read the gauges, things to look for, safety, and so forth today. So moving on to the next slide here. Resealed system service, we got the gauges themselves, how to read the scales around here. What do all these numbers mean on the scales of your gauges? Comparing it to a temperature pressure chart and how that works out. Using the gauges, like what different things do we use them for? The hoses and different types of hoses and hooking them up. Now, the only thing is I didn't get that put together before this class. I've been putting these pictures together. I took all these pictures instead of stealing them from the internet. Down here I have a link. I know you guys can't click on it, but you guys can see it's on yellowjacket.com. I go ahead and I opened it up here and have it saved here. This is a brochure for all their products. And a lot of this stuff we're going to talk about in the sealed systems: recovery machine, vacuum pumps, the hoses, different adapters, gauges, leak detectors, how to use the scale for charging, flaring and swedging tools. I'm going to put a link to this in the video on the website, so you guys can download it directly from our site if you want. But it has a lot of good tools, and I'm going to go over as many of them possible in this class, so you know what they all are and which ones you would want to have or use for your business. So I'm not going to go through this whole thing right now. Let's go through the slides and go through what I put together. The gauges. I went ahead and took this gauge apart and just point out that we have what we call the low pressure gauge, or sometimes it's called a compound gauge. And the reason why it's called compound is that right there where the arrow's pointing is 0 psi. That's gauge pressure. And as we go up, the pressure rises. Now, we're not looking at the black numbers on the outside. We're looking at the blue scale that says 0, then 10, 20, 30, 40. That is psi. That's pounds per square inch. This is one of the numbers you're going to have to be not be careful, but to be aware of. And then 0 to 30 inches in a vacuum, which is in the green down here. So that's why they call it a compound gauge, because it does both positive pressures and vacuums within the system. Now, I took the gauge apart to show this is the inside of that blue valve, that this slides in and out when you turn the knob. And one thing that people don't realize, as soon as you connect the hose to the appliance or to anything with pressure or vacuum, it goes straight to the gauge without touching this handle. This handle should be in the closed position when you're checking pressures. And the reason why I mean that, you say, well, if it's closed, how is it going to read pressure? The valve does not close going up and down. If you look where the arrow is, imagine the white spaces that I have inside the gauge as the inside channel where the Freon flows through. And so when you connect the hose in this bottom left-hand port here, it goes right up to the gauge, no matter where this knob is at. But if you open this valve, what happens is you open right where this arrow is, and you create a passage to the center of the valve, and then that Freon can leak out this opening. So the only time we open or close these hand valves is if we are charging the unit with Freon, or we are pulling a vacuum, or we're doing anything where we want Freon in and out, or we're putting nitrogen in or out. We're going to go through our gauges, but that valve only closes between the left and the center. Now, if you open up both gauges at the same time, if you look at this white channel going through the middle, it opens up through both sides. So let's say you're working on a refrigerator and the pressure on the refrigerator is over here at 250, and the pressure here on the low side is like 10 inches in a vacuum, and you want those pressures to balance out so you can open it up for service. If you open up both the gauges, the pressures will flow through, but if this is open, they will also flow out. So if this was closed off, and I'll show you what I mean by how to close off, you could equalize the pressures in the refrigerator from the high and the low side for working on it. For example, let's say you had a refrigerator running, and normal running pressure on the high side of refrigerator we've discussed a while back was about 125 to 150 psi. And we're going to use the red gauge because that's the high pressure side. And if you turn the refrigerator off and go to turn it back on, well, this pressure is not going to drop until it sits for a while, and then both sides of them will equalize out, and that'll allow the compressor to start. If you attempt to restart it while it's under higher pressure, the compressor is just going to cut off on the overload. So one of the reasons we could use these gauges is to balance out the pressure to try to start the compressor again. But if the pressure is high, we can't get in that. So hand valves should always be closed when we're checking pressures. We only open them to charge, evacuate, put nitrogen in, let the nitrogen out, but we don't ever open them to take a pressure reading. It will automatically go to the gauge as soon as you connect the hose and give you a reading. If you do not get a reading, there could be a couple of reasons why, and I'll talk about the hoses and things to look at, or it could be something wrong with the system. But high side is only positive pressure. We don't measure vacuums with the high side. So some people ask, well, if I don't measure a vacuum with the high side, sometimes I read that when you pull a vacuum on the system, you'll want to open up both the high and the low side here to speed up pulling the vacuum on the system. And that's true. And what's going to happen is your needle's going to go backwards to this little pin right here, but you're not actually going to be able to read what that vacuum is. You're going to have to still use these green numbers up here, this 0 through 30, to measure what your vacuum level is. Okay. Now, the high side gauge. These two gauges are different. Can anybody give me like one or two differences between these two gauges? There's quite a few differences, but they're both high side gauges.
One is giving you the type of refrigerant that is used. This is like 134A 502, which is the one on the left. So basically, this one can accommodate for a different refrigerant, while the other one may not be able to do so.
Yeah, well, this one does have 134A in red on the right, but this is a snap-on gauge that's mainly used for like automotive. If you see, it says R12 on the very inside, so you can imagine how old that gauge was. Even this one has R12 on it. You're right, it has multiple gauges here, but do you guys know what these inner gauges really are? What is this? Yeah, on both of them, we got a red 134A and this R12. And I got 134A and R12 here, but what are these inner gauges telling you?
Telling you what time of the pressure they.
Not pressure. Someone else said something else?
Temperature
Yeah.
of evaporation.
Yeah, and they call it saturation temperature. That's the temperature of the refrigerant at that pressure. And I'll get more deeper into it. But here's a couple more differences. And the reason why I'm pointing out some of these differences is that people go out and they go online and they order gauges. And then when they get them, they're like, oh, I didn't know it was this, or I didn't know it was that. And here's some of the differences. This one is in PSI, but notice this one is in kilograms, centimeters squared. This is metric, okay? And this one is for different refrigerants, like you said. But these are temperatures, but you can barely see it. It's got a C on there. That's temperatures in Celsius, not temperatures in Fahrenheit. So if you look at it, let's just say 100 PSI is 10 degrees on R502 here is 10 degrees. But if I look at, well, I don't have 502. Let me go to one we have. Let's go to the 134A. At 100, if I go right here, that's about 37, 30, no, it's actually like 35 degrees right there. If I use that 134A chart, but that's 35 degrees Celsius at 100 PSI. If I go 100 PSI here, and I'm using 134A, really it's almost 90 degrees Fahrenheit. So, you know, for Adrian, he's up in Canada, it might be more, you know, convenient for him to use the Celsius one because they use metric there, and he's more familiar with metric temperatures and stuff like that. Where if you're in America here, you guys would probably want to use a scale that's in Fahrenheit, so you can use that. Otherwise, you might be confused on temperatures and pressures. Okay, now the other thing is if you noticed, what's going on here with my gauge on this one versus this one here, where I'm pointing at the needle. You see that there? I don't know if
Second pointer.
Let me see if I can. Let me see if I can get my drawing tool there. Right here. See?
PSI?
It's PSI, but if you notice, I'm on 0 here.
It's
but
reading pressure.
yeah, it's reading pressure here. This one is slightly off. It's not that far off, but I'm going to show you another gauge. It's a little more off. And this screw right here is an adjustment screw. So when you throw your gauges around your truck, if you don't take care of these gauges, they're going to get beat up. They're going to get damaged. That's why they got this rubber cover around the outside of this one. I opened this one up to get a better picture of it without a reflection on the glass. But that is for you to calibrate your gauges. Before you connect them to your system, you want to have them not connected to anything. The hose is in the open air. And you want to put a little flat screwdriver. You take this plastic cover off, and then you can get right to it. And you can rotate that screw so you can adjust this needle onto 0 before you start reading your pressures. So let's take a look at the low side gauge. Now, if you look at this low side gauge on the right, the snap-on one, this one is definitely not calibrated. So this one definitely you need to adjust it so the needle's here on 0. And you adjust it by adjusting it on that one screw there. So on this one here, we read pressures and vacuums. So if we looked at this needle right where we're at here, it's a little bit off because it should be on the 0 in the blue, not the 0 in the black, but they're about almost the same there. Now when we go into the green is when we're pulling a vacuum. This is inches of vacuum. And they would say Hg, which is the symbol for mercury. So when you're pulling a vacuum on a system, you would want to use that when you are going to put the system back together again. Let's say you go in, the customer has a bad compressor. When you put the new compressor in, all the lines in the system are going to be filled with air and also possibly have humidity or moisture in them. So before you put Freon, you have to take all of that air and moisture out of the system and pull a vacuum on it. We need to get as close as we can to a 30-inch vacuum here before we can start charging that system with refrigerant. So when you use this gauge, you want to pull it down to right about here, and when it stays there, when you close the gauge, and the pump's not pulling anymore and you're just measuring the pressure on the system, you want that needle to stay in this position right here. Now everything above here excuse me, is positive pressures, and we use those to see if a refrigerator is cooling properly. Now, the problem we have is that this gauge doesn't do 600A, and a lot of us now are going to have to deal with 600A. I'm going to show you guys 600A the next time we have class. And so you don't know its temperature to pressure relation, but can you use these gauges on 600A?
Yes, you can. The pressure gonna be probably a little bit higher than you expected it, but if that's what you have, probably you can get by with that.
That's a good answer. Trinity and Adrian, either one of you guys have something? I saw Trinity, you were going to say something?
That's what I was going to say. What he said.
Okay, well, yeah, you can use them pretty much for any refrigerant. The difference is the pressure is pressure. If you have 40 pounds of pressure of 134A, and you have 40 pounds pressure 600, they're both going to read 40. Okay? The different gases, pressure is pressure. We're talking about different gases. What makes the gases different is their temperature at that pressure. The only thing we do not have on this dial is the temperature that 600A is. And we can use a paper temperature pressure chart to figure that out. So we can use this gauge for any type of refrigerant. We don't have to have a gauge that says, oh, this gauge only does 134A and 502, and you know what, I'm doing R22 or some other gas that's not listed on one of these inner circles. That doesn't matter as long as you know the pressure you're trying to achieve. What's important about the temperature is you need to know what temperature it is at a specific pressure. If you're working on something like Sub-Zero, Sub-Zero has, and let me see if my drawing tool will work today. No, for some reason I just rebooted the computer, so I'm having an issue with that tool. But Sub-Zero refrigerators, for example, have multiple compressors and on some of their units. You got a refrigerator side, a freezer here, and a refrigerator here, and you have a compressor on top for one and a compressor on top for the other. So this one has its own sealed system, and this one has its own sealed system. Now the difference on that refrigerator side is that refrigerator side doesn't have a defrost system. And because it doesn't have a defrost system, its pressure doesn't run like a normal refrigerator pressure. Normal 134A, when the refrigerator's running, is going to be 0 psi. And if we look, and we've talked about this a little bit before, if we're looking at 134A, that's about 15 to 20 degrees below zero on the evaporator. Well, when we're doing a refrigerator section, we don't go to that temperature inside the refrigerator. We're only going to get to about 34, 36 degrees inside that box. So it doesn't have a defrosting system. So you're like, okay, if it has defrost and it has a heating element and a timer and everything, we're going to run a refrigerator at this 0 psi. If we're going to run a refrigerator that does not have a defrosting system like Sub-Zero, for example, that refrigerator side is not going to run at 0 psi. So we're probably going to run it at about, let's say, about right, trying to think, the pressure we're going to run it at is probably about 28 degrees. So if I'm using a 34A, I'm going to run that evaporator at about 28 degrees. So what pressure am I going to use? I don't think this chart's correct. I need to look it up. I'm going to have to mute you. Sorry about that. So we want to run at about 28 degrees. So we use the temperature pressure chart here. And when we look at the temperature pressure chart, we're going to have to look at the pressure. Now, again, The problem we're having is this is not Fahrenheit. So let me go over to the Snap-on one. And if I'm going to run it about 28 degrees with 134A, 28 degrees is about right here. So my pressure is going to be about 25, 26 psi. So 34 degrees, we go about 10 to 15 degrees colder. So let's just say minus 10. And I'll put about 24 degrees. What am I talking about? Well, when you are creating cooling, the evaporator on your system has to be about 10 or 15 degrees colder than the air you're trying to cool. So if you're using an air conditioner, you don't want to get colder than 36 degrees, but it has to at least be 15 or 20 degrees colder. In your freezer, you want a freezer temperature about 0 to 10 degrees. 0 to 10 degrees, for example. So we're going to run the evaporator on the refrigerator about 15 below 0. And that would be somewhere here. And the refrigerator side, if we don't have defrost, we're going to run at 34. So we're going to go about 10 or 15 degrees colder. So we're going to be somewhere around here, 20 to 25 psi. Now, the good thing about it is when we're charging with Freon, we can measure the charge in. And I'm going to show you guys 2 different methods to weigh refrigerant in one of these classes. But if you don't have, says give me 3 ounces or 6 ounces of 134A, if you don't have the measurement of what to charge in the system, or you want to test a system and say, is this system, working properly inside, you have to know the pressure that it's running at. And in this case, 20 to 30 degrees is what we want the evaporator so that we can get the temperature to about 30 to 40 degrees. And then over here is the pressure we're going to run it at. So using the temperature pressure gauge is if you know the temperature that you're trying to achieve, you minus 10 or 15 degrees, then you know the pressure it's running at. So what's the point of all that? A lot of people, when they hook up gauges and say, oh, I got pressure, but how do I know if the pressure in that system is right? I mean, that's the pressure it's supposed to be. Because when you look at the refrigerator model and serial number plate, it tells you test pressures, which is how much pressure they put in there to make sure the pipe don't break. And they tell you 3 ounces for the charge, but they don't tell you what is the pressure of the refrigerator when it's running. And that's where you as a technician have to know, okay, what type temperature I'm trying to achieve. I'm achieving 34 degrees. Well, it has to be colder than 34 because it has to be able to absorb the heat. So 10 to 15 degrees colder will drop that from 34 degrees. I'm just doing it one more time. 34 degrees would be like about, let's say about here, 34 degrees. That'll put me here. I need to go 10 or 15 degrees colder. That will put me to 24. So what am I running? About a 20 to 24 psi evaporator. And if I'm at that pressure, then I got a good charge. Now, I know a lot of you are like, what did he just say? If you got any questions, ask me some questions about this before we move on to anything else.
Not a question, but I don't know if you talked about it before. A good easy way to do this is the Danfoss app. Makes it much easier.
It's easier way to do what?
To convert.
I didn't get the last.
To convert to correlate the saturation temperature and the pressure. Familiar with the Danfoss app, the ref tool?
I'm not quite understanding what you're saying. I don't know if it's your mic or I just never heard the word before. What's that word again?
Danfoss application on the phone.
I never heard of that.
He used that, Adrian. He uses the PD chart to do that, what he just did.
Yeah, but Adrian is discussing another I guess it's an app or something. DabFOS app.
Is this an application when they put it in an app?
Yeah, he just. I'll check that out, Adrian. It's called DanFOS app. Okay,
Memphis. Yeah.
I've never
Is
heard of that.
is a calculation app that converted the pressure temperature for you, and then you don't have to you just put the data on it, and then he converted it for you.
Okay, well, I have not.
So is that equivalent to superheat?
No, it's superheat is a measurement of we talk like the line or how much heat the refrigerant has absorbed. We're measuring the pressure, but we want to know the saturation pressure of the evaporator to calculate the temperature. Does that sort of make sense? When we don't normally measure superheat in refrigeration systems. I mean, they do have superheat, but that's usually when you're charged like a central air conditioner. You measure superheat, which is measuring the suction line pressure, the suction line temperature, and the ambient temperature. And there's a chart where you can put those three readings on, and it tells you what the pressure should be based on the superheat. But what we're looking at is, and I'm just saying it's not really a formula. What I'm saying is I'm just saying, let's just say you're doing commercial refrigeration and you're going to do a reach-in or a refrigerated table or something like that, and you want to know, okay, well, how do I know what's the right pressure on this particular unit? Well, first of all, you have to know, well, what temperature do you want to keep that refrigerated table or that refrigerated unit? Is it a freezer? Is it a refrigerator? What temperature do we want to store something at inside that compartment? If you're doing a refrigerator and you want it to run at 34 degrees, well, the evaporator has to be at least 10 or 15 degrees colder so it'll absorb more heat. So then if you say 34 degrees minus 10 leaves you 24, then you could look at the pressure and say, that's how I know the approximate pressure that the unit is supposed to be running at. So if you walked up to that refrigerator for the first time and you put a valve on it and you want to know what the pressures are inside the system, it's like, how do I know what the pressure is supposed to be? Because every refrigeration system, commercial-wise, the pressure is different based on the refrigerant you're using. So this 34 degrees minus 10, 24 degrees, well, still the pressure here is only based on 134A. If I was to go to a different refrigerant, I still wanted 24 degrees, I would have to use that temperature pressure chart. And I have that in the next screen here. This was my next thing, is that you could go to the temperature pressure chart and say, well, if I want 24 degree evaporator, and my temperature here is 24 degrees, my pressure is going to be 21.3 psi. And that's how I use the temperature pressure chart. Now, I'm not familiar with the DanFOS app that Adrian was talking about, but I'm going to check it out as soon as class is over.
Hey, can I add something?
Of course.
There is an app that on Android that I use, which is HVAC P/T. It's by Adams Air. It lists all the different refrigerants along with the pressure and temperature correlations. So it has tabs at the top: R22, R410A, R407, R134, 404, and then you just it converts it for you.
So basically, it's similar to this temperature pressure chart, but it's in an app.
Yeah, it's just an app on your phone.
Okay, yeah.
Exactly.
I sometimes just use Google and type in this at this pressure, and I get the number from Google. But it's And the question is, though, is how do you know what pressure you're supposed to be running at? You follow what I'm saying?
You get the pressure from the gauge.
Well, you
The
get
pressure you read from the gauge, you plug it on the app, and then it gives you the evaporative
temperature.
Basically, it works both ways. You can put in the pressure and it gives you the temperature, the saturation temperature, or you put in the temperature and it gives pressure. It works
Okay,
both ways.
so it's this chart using it one way or the other, but you see how
It's the same thing.
So you see how, though, you still have to figure this out because you need to know, okay, what's the temperature that compartment's going to be? The compartment is going to be 34. Approximately what should my evaporator temperature be? 10 to 15 degrees colder, so it'll absorb heat, and then you got to go to the chart. Now, if you just put gauges on a system and use that temperature pressure correlation software, it's just telling you what temperature it's running at, but you still have to say, how do I know that's the temperature I'm supposed to be running at? Do you understand what I'm saying? So the chart, whether it's on paper or it's an app you're using on your phone, it's going to tell you the temperatures or pressures that you have or whatever, but you need to know, how do I figure out if that is the right pressure it's supposed to be? Go ahead, Rochelle.
So that correlates whether you have a dual evaporator or a single evaporator, correct? If you have a single evaporator that's only located in the freezer
Well, here's the problem
compartment.
with dual evaporators and the newer refrigeration systems. These compressors, these variable speed compressors, they affect temperature and pressure as well. If you're running one evaporator or two evaporators with the same refrigerant, the pressures are going to be not as accurate as a single evaporative system, where if you just have a plain Frigidaire top mount unit, it's going to read 0 psi all day on the low side while that compressor's running all day. But if you're going to a dual evaporative system, you're going to have to say, well, I'm going to be, if that freezer valve is open, I got to be about 0 psi. It may run at 8 or 10. It may run a little bit in a vacuum, depending on if the other evaporator itself is open and you're feeding both evaporators. Now remember, dual evaporative systems, that's a whole nother can of worms, because, and that I was thinking about, I was telling you, is in some units, they don't have a two-way valve, or a step valve they call it, and both evaporators are always on and they're in series with each other, and it's always going to maintain a constant pressure. Where if you have a step valve where it only does the freezer or only does the refrigerator, the pressures are going to vary, and that's going to be very difficult for you to determine if you have the right pressure in the system. You don't know what it's supposed to be. So the only way really to check pressures is to, if you have a step valve and you have, a variable speed unit, is you have to go into diagnostics and force that refrigerator into a max cool, max freeze operation, where the compressor's running at the highest speed and the valve's open in this position, so you can get a more accurate reading. Because when you hook a gauge, you don't know whether one valve's open, both valves are open, where's the freon going when you're just hooking up a gauge to the unit.
So, Richard, I have a question, sir.
Yes, go ahead.
Is this similar to like the LG issue, where you have to put the valve in the home?
Yes, if you don't put the valve in the home position when charging the unit up, you only have one evaporator open when you're charging. Then when you're looking at your pressures and the pressures look good and you leave and the customer calls back and says it's not cooling right, well, that valve may have changed positions between now and then, and now it's undercharged. Because I'm going to tell you right now, I've been doing this a long time, and I've been teaching for quite a long time, and I tell guys, weigh the refrigerant in, put a scale, use a charging scale, Brandon just stepped in. So, Brandon, I'm glad you came in because I'm going to pick your brain for a second. So when you're charging refrigerant into a system, you want to weigh it in with a scale or a dial-a-charge, and I'll show you guys both of them, where it measures the exact refrigerant that goes in a system, especially ones with a step valve like the LG one that you spoke about, because that way you're not going by pressures and saying my system is properly charged. Brandon, real quick, a question Ms. Ward asked was about the step valve in the home position. That if you charge it, the step valve's only opening one evaporator. Most technicians, and I'm sure you probably have done the same, charge by pressure. You go in, you see the gauge at 0 psi, and then you walk away. You know, I've done that quite a few times too, where I didn't weigh refrigerant in. I looked and I saw that, 134A or R12, I'm at 0 psi. I know I got a good pressure here. I'm good. I'm moving on to the next machine. This is not going to work if you're going to have a dual evaporator or step valve within the system. So that's why you have to open up that valve and put it into the home position so all the evaporators are open. One, so when you're evacuating the system, you get all the air out of the system and nothing gets trapped into one of those evaporators. And two, when you're checking pressures, you're checking it with all the evaporators open. So I hope I answered that question there. So I don't know if Brandon can hear me. Any other questions on that?
A weighting scale versus I don't know the name. The container with a scale.
Dial-a-charge.
So it. Yes.
Give me a second to bring up an image of that.
But wait,
Yes.
if you're not sure with the charge that already in the fridge, so basically the way you probably can do it though, just withdraw the charge that already in the system, and then start fresh with the charge with this spec from the manufacturer. I think that would work the same way as well.
That's true, but wanting to know the pressure of the system before you service it and replace anything to try to get an idea of diagnosing the problem, you want to know if you're in a restriction, you're overcharged, you're undercharged. So you have to have a general idea
I got you.
of knowing pressures. You can't just, okay, well, I'm just going to dump all the charge and charge it back up. And on some of the LG compressors, a valve goes bad, and now you have bad pressures in the system, and you really didn't diagnose it. You just took a dryer filter and put a new filter in, and you had the same problem. So you have to know roughly what the pressure should be at the temperature you're running at. So when you put your gauges on, you have an idea of what the running pressure should be. So whenever you guys get a chance to access the system of a new refrigerator or refrigerator that's working properly, get an idea of what these pressures are, so when you're troubleshooting and diagnosing, you can also see what those pressures are. Now, I brought up on the screen to answer a question Adrian had. The one on the right is a charging scale. So those scales like this here is you put your tank on it upside down, and the little scale here measures like how much Freon leaves that tank and goes into your refrigerator. And we only need like 3 or 6 ounces. And when it goes -3 or -6, I know that that's how much refrigerant left the tank that would be sitting on here. I don't see any pictures with a tank on it. Oh, here's one like this, which it should be upside down. But these are all different methods of weighing refrigerant in through a scale. Well, this other device here called a dial-a-charge, I have one of those in my classroom. There's a little glass tube in there, and you can actually see the refrigerant in the glass tube. It looks like water. And when I open this up, you see this little rubber band wrapped around here. There's a little black line. It's a little hard to see on some of these. I don't know if I get a good picture of one. Let me see if this one has a good picture. Let me zoom in on it. The quality's not that good. But there's a black line here. So this, from here all the way up to here to where this gauge is, the refrigerant is trapped inside this little glass tube. and you charge it from the bottom. You turn your tank upside down, and you let the Freon in here, and the Freon starts to rise up. And that's a clear glass tube, so you can actually see it looks like water as it's starting to rise. Now, each one of these lines here represent, I think, a half a pound. So like half a pound, 1 pound of Freon, 1.5 pounds, 2 pounds. And the little lines in between are ounces. So let's just say the refrigerant is at this black line here, and you need to take 6 ounces out. Well, you count down 1, 2, 3, 4, 5, 6, and this is like a rubber band. You move it down to where the 6th ounce is right there, and then you connect this to your refrigerator, open the valves, and as the Freon runs out and runs into the refrigerator, you see it dropping down. When the liquid drops to this line right here, you just close this hand valve and you just let 6 ounces out. The nice thing about a dial-a-charge is that you charge this up, you're not carrying a 30 pound of refrigerant in and out of a customer's house. They even had small ones of these that hold like 1 pound of Freon. And a 1 pound unit can do 3 or 4 refrigerators depending on how much they take. So this here made it easier to charge and to also measure without a scale. It measures as you let the Freon out. You can actually see it dropping and stop it when you reach that volume. So that did answer you guys' questions about the scales and the dial charge?
Rick, I actually purchased a used one of those, and mine has 16 ounces on it. I hadn't used it yet, so I do have one.
If you can send me a picture of a 16-ounce one is one of the smaller ones, and I would love to get my hands on one of them. Those are the best ones because you put the Freon in that, and you just carry that into the house. You don't have to carry the tank. You don't have to carry a scale. You just got this small little device that has your Freon in it, and you can use that to control the charge. Any other questions about that?
Is there anything that charge device cannot do where you would still need to have a scale? Or is it like if I were to buy a charge unit, basically I don't need a scale, right?
Yeah, the dial-a-charge is the scale, and that's what we used in our day. I mean, remember, I started working for Sears in 1983. We didn't have scales, and we didn't recover refrigerant. Now, you would need a scale when you're doing refrigerant recovery only to make sure that you don't overcharge your recovery tank. But you wouldn't need a scale to charge the refrigerant. So a scale might still be necessary because back then when I started working on this product, we didn't have scales. We had dial-a-charges, and that's what we used to measure the refrigerant to go into a refrigerator. But we didn't recover. We didn't have a scale at the time to measure and weigh, and even then there was really no digital products out back then. We didn't even have cell phones or beepers, so that's going way back. So in answer to your question, do you need a scale to charge? No. Do you need a scale? Probably yes if you're going to recover refrigerant, which, technically by law you're supposed to recover. You're going to need that scale.
Got it.
So
thank you.
No problem. So temperatures and pressures are important, and getting used to refrigerators and what temperature or what pressure they're running. Now that we're running with 600A, now we're doing a whole new temperature pressure relation. We bought these kits, and the kit was put together. I forgot who it was. Let me see if I can find a picture of that while I'm talking. Is that there is a 600A kit that people are selling, and I don't think it was worth the money to buy this kit, and I'm going to explain why and what we did. I do have 2 of these kits for my business, and here it is right here. Dynamite Unlimited is my friend. I'm not going to tell you who they are, but he is selling this stuff. This is the charging kit. It's made by Vulcan, who also makes Lockring, the tool, and we'll learn how to do that in the future. So there's a scale that comes with gauges. It comes with all these adapters and fittings. And those themselves is like, you don't really need all that stuff. I learned that some of these hoses, they leak. They don't allow you to pull a deep enough vacuum. Instead of having one manifold for high and the low side, they had separate high and low side gauges. This scale is the same as the ones that they use to weigh pills and stuff like that. We found out that the 600A cans, these small ones that are like in this picture right here, they sit on top of a regular scale. So the same scale I use for 134A I can use. And if you could see these two pieces right here, I have one of them sitting next to me. These two pieces allow you to take a can like this. There's a little bit different, the can. It's more like the one the guy's holding. And put the can upside down into the top here. This red knob is the valve to open and close that. And then all this is a weighted piece to hold the tank upside down so you can measure with the scale the 600A as it leaves. So I just ordered from Dynamite Unlimited. As a matter of fact, I ordered it from Dan himself. These two pieces plus this super long hose. I just ordered those three things. I ordered 15 of each, and it was close to $1,500. But this hose is the hose that you connect to the refrigerator, and you can run it, about 20 feet, 15 feet away from the fridge to vent it outside if you can vent it outside of the customer's home. So I know I'm getting off track, but this is all part of the charging and connecting and everything. So do you need to buy this whole kit for a couple of grand? I don't really think you need it. Like I said, I just bought these two pieces right here, and they're in the picture here. The charging stand and recovery valve. So if you look here, the charging stand and recovery valve are here on the, I think they're here somewhere here. I can get you guys the part numbers of the ones I ordered, plus this hose at the very bottom right here, this evacuation hose. And it has a check valve so it doesn't go back into the system. It allows it to free flow out. So all I ordered was this, and this, but I ordered one for all of my technicians. And then I told them, use your regular gauges, use your regular scale and everything else, and you'll be fine. But I really don't think you guys need that entire kit. Here's another picture of that kit close up. You don't need all that stuff. Okay? So that's for 600A. Now, refrigerant hoses. There's all kinds of hoses, and you have to take care of your hoses. That's super important as far as safety. These hoses, over a period of time, start to get cracks in them. I'm sure you've seen like tires that get dry rot and they get cracks in them, or old hoses. Like you leave your garden hose out in the yard too long, after a while it gets split and cracked in there. You have to really maintain your hoses and make sure that you keep the ends of your hoses clean and free of debris. When you connect them to your gauges, the straight end of the hose connects to the gauge. You have these hoses, a lot of people just let them hang down. You need to reconnect them back to the gauge on the back side where they have like the second holder, so that dirt doesn't get in there and the hoses don't get damaged. Now the difference on some of these hoses is that if you see this one has a hand valve on the end of the hoses, and this one has what we call a low loss fitting. And you can see it says low loss on here. Both of them serve the same purpose. This one here, when you connect it to the appliance, and when you disconnect it, it has like a valve like inside of a car tire, that any refrigerant that's in the hose doesn't blow out into the air. That refrigerant stays in the hose. And the same thing with this hand valve. Before you disconnect it from the appliance, you can close off these hand valves. Now they sell adapters like this that you can add to existing hoses, but you have to be careful. Some of these hoses, when you start to add all these little added conveniences here, sometimes you have more places they could leak, and you have to be careful that your hoses aren't leaking. Now, with the low loss fittings versus the hand valves, I like the hand valves, but I also have a negative against them. The low loss fittings, because they put a little valve inside that hose, when you're pulling a vacuum on the refrigerator, you're charging the system with refrigerant. That valve is like a little restriction in the hose. It allows you to pull a vacuum and charge, but it controls the flow. And it takes longer to pull a vacuum on the system, and it also takes longer to charge the system up because it's got like a little valve inside of it, and it's in the flow of the refrigerant. Now the hand valves have pros and cons as well. Right now, as you see them across the hand valve of the hose, they're not the same direction of the hose. That means they're closed. You can see these here as well. So that's how you would close them off. And when you open them up, they open the hose wide up. So when you're pulling a vacuum or charging, this one allows for faster vacuum time than these low loss fittings. Okay? So these here are better, but I've seen where the little handle goes through the valve, sometimes you get a leak through there, and sometimes you have to pressure test them with nitrogen to make sure that they don't leak. So just like checking your gauges to make sure they're zeroed out before you use them, I recommend periodically pressure testing your hoses with 100 psi of nitrogen, and then use a little soap and check the fittings to make sure they're not leaking and make sure that they're maintaining the charge. Now the other thing is some of these hoses have different ends, so when you order hoses, don't just go online to eBay and Amazon and order these cheap hoses and find out the fittings are the wrong size or they're so cheap that they leak. So there's many different hoses. Normally we deal with 1/4-inch fittings, but I prefer the hand valve over this. Now I took some pictures of some hoses that I have here, and take a look at the picture on the right. If you notice that the hose on the bottom is a straight piece, where the hose on the top is angled. The angled portion is the one that always connects to the valve on the appliance. If you're using a valve that has a Schrader core inside of it, that is like the same core as like a car or bike tire, if you notice on the top one, it has a little metal prong in there, and that's used to depress on that valve. I've had people connect this end to that valve, and they pull a vacuum, and the vacuum runs for a little while, and they say, oh, I got a great vacuum. Look, I got 500 micron vacuum. I'm ready to charge. They go ahead and they start adding the Freon, and the refrigerator's not cool, and it's like, why am I not charging? Well, they had this end connected to the refrigerator, and it wasn't pressing on the little valve, so when they pulled a vacuum, they only pulled a vacuum on the hose. When they went to charge, the Freon's sitting in the hose. It didn't go in the appliance. You need to have this piece right here in the middle to press down on the valve so you can recover, evacuate, or charge. If you have this end of the hose connected, there's nothing to press down on the valve, and that's not going to do anything for you. So if we look at the next picture, you can see here that here is the valve where you want to make sure that when you pressure test it, put 100 psi in here, check to make sure it's not leaking here, not leaking any of these fittings here, not leaking any of these fittings here. This fitting can be taken apart, and you can use Teflon tape if you have a leak, and make sure that your hoses are not fitting. Now, I had one other picture. I guess we'll just use this one here. Let me maximize this picture because I want to show you guys something a little bit more detail. Can you see that right there around the outside? That is the rubber seal when you connect it to the valve. Look at the condition of that seal. If you're trying to pull a vacuum, you might not get 500 microns when pulling a vacuum if that seal is corroded or damaged. Both ends of these hoses have seals on them. This one has got oil on it. This is, believe it or not, this is the same hose. It's just the two ends of that hose. But that seal doesn't look corroded, but what do you see there? What do you guys think that is, the white spots on it? Anybody have any idea? That's dirt or dust. And if you have any debris on that rubber seal, you're going to have a problem evacuating it. Now, a lot of these hose manufacturers sell these seals that go inside of here, and even this one either pulls out or unscrews out, and you can replace these, but you can replace these seals. So you need to periodically check your seals to make sure they're not damaged, or like this one here has got oil or dirt on it, and it prevents you from making a good seal to your hose when you're pulling a vacuum and charging. One of the reasons why this one looks like it is because what happens is people take an access valve and they solder what they call a stem valve, which is one that you use a torch to add it to your compressor or to your system. And while the valve is still hot, they go ahead and put the hose on. Well, it doesn't burn them because they're touching this metal around the outside, but that heat of the valve is going to melt or damage that seal on the hose, and now you've just ruined that hose. So if you can replace seals or keep spare seals on your truck, you need to periodically check your hoses, check your gauges, and check your equipment, because I have seen people go and test pressures and charge and evacuate systems and can't get the vacuum, can't get the proper pressure, can't get the proper charge. And it not necessarily was the problem with the product. It was a problem with their equipment and their tools. So you have to keep these hoses safe, clean, and prevent these seals from getting dirty, damaged, torn. If they're bad, get new hoses. Always buy it. When you buy a set of gauges, spend a few extra bucks, buy a set of hoses, extra set of hoses, keep them in a Ziploc bag or in their original sealed bag in your truck. So while you're doing a job, if one of your hoses break, bursts, or one of these seals go bad, you got a replacement hose right there ready to go do your job. This is something that you really need to carry with you when you're doing refrigerant work, because the worst thing to do is to be in the middle of a job, and because of one tool not working, you can't complete the job. I think we're running up across the hour right now. Does anybody have any questions or things you want me to go over?
Rick.
Yes, sir.
Rick. Excellent class. I wanted to mention something though. I got an email from Fortuna, but I didn't know how to, and maybe you can. He wanted to know about lock ring equipment. Where can you direct him to?
I will.
I'll forward the email he sent me. I don't know. I don't do R600 yet.
And believe it or not, we bought a bunch of lock ring tools, and we teach lock ring at the school. But Robert and I, my partner, guys, if you don't know my partner from my business, we found that a lot of people in Europe are using torches on 600A systems, and we believe that if you service a 600A system properly, you don't need to use lock ring. We changed the compressor, that Samsung compressor that Brandon and I are going to do a video on with 600A fittings, and found out that we had more problems with those fittings leaking and not working, and it was just easier to take a torch and complete the job. But we'll explain when we get to the lock ring part of this class, like the safe things. What can you do? Can you use a torch? And if so, how to do it safely and properly. Anybody else have anything else to say or add?
Thank you.
No problem. All right, everyone. If I've answered all your questions, we've come up amongst our hour. I will clean up this video just a little bit. Now I'll post that video up on the website probably by the end of this weekend. And those who weren't able to attend can watch it. And hope to see you next class. Remember, Thanksgiving, we're not going to do any classes that weekend. We're going to observe the holiday. We know a lot of people might be traveling, visiting family, and all that. So we're going to skip one day, and that's on the calendar. We're getting close to wrapping up some of the classes. This refrigerant class is going to go longer because there's still a lot more stuff we need to cover. But some of the other classes, when they end, Brandon and I will come up with the next curriculum for the next class that we'll be adding in its place. other than that, thank you everyone for coming. And
And
go ahead,
and if
Brad.
I may say one thing to elaborate on what Rick is saying, I highly urge you guys to visit those videos and rewatch them because, like he said, once we're complete, we're probably gonna remove them from the website and package them as individual a la cartes for people who want it, and we're gonna replace those videos with new videos. So go over them, check them out, really go through them, make as much notes as you can, so we can make space for new videos, like new courses that we're gonna teach.
Yeah, and Adrian, you said something about sealed system tools. Start off with that. That I told you I'm put a link to this PDF document here, which has a lot of sealed system tools, vacuum pumps, micron gauges, scales, and everything else. Yellow Jacket's just one company, but this brochure here has multiple pages. This is just one company. Look here, this guy has an app on his phone. He's using digital gauges, and he's reading his phone instead of reading it off the gauges. That's too much money. Don't waste your money on junk like that. But here's vacuum pumps, recovery machines, tools, and explanation of all these different tools. So I'm going to post this, but there are other hand tools like swaging, and capillary cutters and stuff like that may not be on here. We will discuss that stuff too. That is part of the curriculum, I think, of the class. Give me 1 second here. I'm just going into our TMM site, just so you guys know. When you click on courses, just the courses itself, here's where we are right now, in the gauges, vacuum, charging, lock ring, accessing the system, readings, brazing, leak detection. So we're only here in chapter 3 of our refrigeration sealed system course. We might, and I'll talk to Brandon, instead of adding another course, maybe doubling up and replacing one of the courses that are going away for the sealed system, so we can get that one wrapped up as well. But we're only like halfway through the sealed system. We're right here on the gauges. The next time we're going to do vacuum, charging, and recovery all in one class. So depending on time and everything, we're going to go through all this material here.